All right, as I said in the beginning, one of the keys to factoring in general is being able to factor out constants. So when we look at our AC, what multiplies to be AC and adds to be that middle B term, oftentimes, if we're lucky, the numbers are small enough that we can just list out the factors in our mind. But if they're larger numbers, sometimes that can be a little bit difficult. And I've run into enough issues with people in my classes to where we really have to look at factor trees and how those can best be used to help come up with those combinations of factors. So we're going to look at 56. You can think of any number that evenly goes into 56, besides 1, of course. I thought of 8 and 7. So we're going to go there. You can start with 2 if you wanted to, because you know it's even. Then, of course, we're going to break that up into 4 and 2, and that up into 2 and 2. Yeah? So that means that those product of prime factors that make up 56 are 2 times 2 times 2 times 7, and I also put a times 1 to remind myself. Does that make sense? Okay, you should have done this before, so it shouldn't be new to you. But again, we're trying to make the connections between those factor trees to help us factor out our numbers so we can get the A and C that work. Okay, 150 divisible by 2 or 10, so I'm going to choose 10 and 15, break that down into 5 and 2, and that down into 3 and 5. So my product of prime factors, again, is 2 times 3 times 5 times 5 times 1. Okay, 198. This might be a little bit more difficult to think of unless you know your rules. Those rules that for example, we learned that if a number is divisible by 6, it's divisible by 2 and 3. Those were rules that we learned back in elementary school, but they're often hard to remember. So let's say you don't know, and you just know that it's even. Okay, you know it's even, so it's divisible by 2. 2 and 99, yep. You can break that down into 11 and 9, and you have 2 times 9 times 11 times 1. Yep. Oh, and you can break down 9 into 3 and 3. Thank you. That's not a prime. So that would break down. So 2 times 3 times 3 times 11 times 1. Yes. Okay, are we good? Yes. Just to remind myself when I'm putting together the factor pairs that one of them is going to be 56 and 1. I'll show you. Okay? So, I want us to, for 4, 5, and 6, relist these product of primes. So 2 times 2 times 2 times 7 times 1 for number 4, 2 times 3 times 5 times 5 times 1 for number 5, and 2 times 3 times 3 times 11 times 1 for number 6. Okay, so we're gonna list the product of prime factors like we did. So for number 4, I have 2 times 2 times 2 times 7 times 1. We're going to work with that first. You'll see why I listed that one here in a second. So we ask ourselves oftentimes when we're factoring what multiplies to be a certain number and adds to be a certain number, right? So we have to think of combinations of 2 numbers, yes? That's what we've been working on. So this is what I do. I start from the left and I move to the right. I say, okay, I'm going to use 2. Start with 2. 2 times what is a pair? 2 times 2 is 4. Times 7 is 28, right? So 2 and 28 is one pair. Does that make sense? And then I go to the next 2. That's 4. 4 times what? 4 times 14. That's another pair. Does that make sense, what I'm doing? And then I go to my next one. Okay? I go 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. 8 times 7 is 56. So 8 and 7 works as another pair. Yes? Does that make sense what I'm doing to get all my factor pairs? Because again, you have to say what multiplies to be something and adds to be something. Well, in order to do that, you have to know what all those pairs are. And then, of course, I have 2 times 2 times 2 times 7, which is 56. 56 and 1 is that last set. Does that make sense what I'm doing there? And then what I do is I go back and I say, okay, do I have all the rest of the pairs? I have 7 times something, I have 14 times something, I have 28 times something. Okay, I've gotten all the pairs. Sometimes you have to go back and look backwards and make sure that you've got all those factor pairs. Does that make sense? So now these are the ones that you can work with when you factor out your polynomial. Okay, let's do the same thing with 150 and 198. So for 150, we have 2 times 3 times 5 times 5 times 1. Okay. So 2 times 3 times 5 times 5 times 1. I'm going to work with 2 first. 2 times 1. 2 times, well, I have 15. What's 15 times 5? Yeah. So you have 75, right? And then you do 2 times 3, which is 6. 6 and 1. 25. Do you all understand what I'm doing? And then 2 times 3, which is 6 times 5, which is 30. Yeah? And then another one, which is 150 times 1. Now just doing this, you don't necessarily have all of them. You have to go back and check if you've accounted for all of those numbers. So have I? What pair have I not accounted for? I have 5 and 30, 25 and 6. What about 10, right? 5 times 2 is 10. That's another one. So yeah, you have to go back sometimes. So you have 10 and 15. And now I have all my possible factors. Does that help you out a little bit? Hopefully. Because I remember that one that we did where we had an AC of like 210, and most of you guys just stopped there. And some of you saw that thankfully it was 21 and 10. But sometimes it's not that simple. Again, you have to list them all out. Well, how do you list them all out without just guessing, right? Well, you do this. You break it down to product of prime factors, you come up with your pairs this way, and you experiment with them. Okay, what is my middle term 77? If it is, then this will work, yeah? The first pair. Do you have any questions about that? I don't think we have to go through 198 unless you want to. Do you have any questions? Okay. None? Okay, hopefully that helps. If it doesn't, you can always just test. You don't have to write this down. I'm just going to talk about it. You can write it down if you want. But I'm just saying, when we're looking at the signs of our P and Q, whenever we factor things completely, well, if we have 2 pluses, we have an AC that's positive and a B value that's positive, we're going to have that P and Q term also be positive. That makes sense. A minus and plus, you're going to have a minus and a minus. So you can think of, for example, just think of a number in your head. Like think of 6, for example. If I have an AC that's a positive 6, and I want to think about what multiplies to be positive 6 and adds to be negative 5, what 2 numbers am I going to come up with? Negative 3 and negative 2. So it makes sense that you have two negatives. Does that make sense? Yeah? Okay. Same can be said about plus and minus. When you have a plus bx and a minus c, you have a plus and minus. These signs, doesn't really matter the order here. It just depends on the number, which is larger. And then when you have a minus minus, you'll have a minus plus or plus minus. So really, the only time where you have the same sign in between your x and p and x and q are situations number 1 and situations number 2, when you're dealing with just positive numbers, so plus bx plus c, or whenever you will have a minus sign in front of your b. I don't know how much that's going to help you. Some of you it might. Okay. Bottoms up method is new. It's new to me. It's new to several teachers. I've never heard of this before, but I like it a lot because it's quick and easy. You still have to do AC whenever you don't have a coefficient that is 1, and you can't pull out a GCF so that it is 1. So again, we ask ourselves if we can pull out a GCF. As the last two, this is the same problem. We know that we can't. So we're looking at AC again, and I have an AC of 12. I can set up my X. And I ask myself again, what multiplies to be 12 and adds to be 13? And as you guys have said before, we get 12 and 1. So far everything's the same, right? Everything's the same as the last two methods. This is what's different, okay? To start the bottoms up method, you're going to proceed as follows. You're going to say, okay, so I'm going to write x plus 12 times x plus 1. So proceed as though you don't have that coefficient. Okay? Now how does the coefficient make a difference? All you're going to do is you're going to divide by that coefficient. You're going to take this number, divide, take this number, divide, reduce when you can. Okay? And if you can't, you're going to bring it from the bottom up. Yeah? So this becomes x plus 3 times 4x plus 1. Does that make sense? Yeah, I love this method. I've never saw it before this year, and I like it a lot. It's really easy. You just remember, okay, I like the x method. I know what multiplies to be 12 and adds to be 13. You still have to remember that AC, 12 and 1. And then you just proceed as though that coefficient weren't there, and then you just divide by that coefficient, reduce your fraction. If you have a fraction in the end, still, you bring that to the top. Bottoms up. Any questions? This is nice. I like it. The second one does not always go up. It only goes up if you end up with a fraction that you can't reduce to a whole number. Yeah? So 12 divided by 4 is 3. Yes? 1/4 is just 1/4. So I have a fraction. If I have 1/2, I'd have to move it to the top. Does that make sense? I have 1/4, so I have to move it bottoms up. You will get a fraction. Well, you won't get a fraction as a part of your factor here. No. Not for what we're dealing with now. Yeah? Okay, let's go to the next one. Alright, these are the same as last time, so I'll give you... Alright, so set up my x here. Find my AC. My AC is 6. My b value is a -7. So again, what multiplies to be 6 and adds to be -7? We came up with -6 and -1 like last time, right? Okay. So where do we go from there? Again, you just proceed as though you do not have that coefficient, like you would any other x method when you just had a coefficient of 1. So now you say x minus 6 times x minus 1. And then you divide each of those numbers by that leading coefficient of 3. Okay, and then bottoms up if you can. So the first one can reduce, so I have x minus 2. The second one cannot, so bottoms up. So now that's 2x minus 1. Oh, 3x minus 1. Alright, does that make sense? Do you like that method? I like it too. It's really nice. Okay, let's do the next one. Do you have any questions before we move on? Yes.
That's when you're gonna make this too specific.
No, I wanted to expose you to all of them for two reasons. One, I don't know who your Algebra 2 teacher is going to be and how they're going to teach it. So that way, you've kind of covered all your basics. If your teacher likes grouping, then you know how to group. If they do the box method, then you know how to do the box method. If you know how to do this, and plus you have this as your own arsenal. So if you get to that point and you want to use this anyway, you can. You know how to use it. Yeah. I will not make you because you're trying to get to the same end goal. Does that make sense? And the second part is, I want you to find something that you are comfortable with because factoring is such a hard topic. If the visual method works for you with the box, then do that. If factoring by grouping works for you and you know you're going to have to use it later on in different cases, then go with that. If the bottoms up method works for you because it's nice and easy, you just have to do it with fractions. The only hard part with bottoms up is, again, if you get an AC that's like 198, right? And then that's when you set up that factor tree. Yeah? So, let's work with the last one here on this page. All right. AC is -14. Our B value, -5. So our P and Q were -7 and 2. X minus 7, x plus 2. Divide by 2. Divide by 2. Reduce if you can. Cannot here, bottoms up. 2x minus 7. I can here, x plus 1. Okay, questions on the bottoms up method? Do you have a favorite? How many of you like the bottoms up method the most? Okay. How many of you like the bottom? All right. So, what do I remember about a leading coefficient that is negative? What do I do with the negative? I change the signs, right? I pull it out, change the signs. So I pull that out, I change the signs. 4x squared plus 8x minus 5. Remember that? Make your little x. My AC is -20 now because I just worked with the inside. AC is -20. B is +8. Okay, P and Q are 10 and -2. Yes? Now, you still leave that negative out, and then we have an x plus 10 and an x minus 2. Okay. So, now we divide by that leading coefficient of 4. Still just working with the inside here. So, wait a minute. Sorry, not there. We divide this by 4. Sorry, this is still a little new to me. What do you notice here? You reduce, you still get a fraction, yeah? So you're still going to do the bottoms up thing with the reduced part of it. Does that make sense? So you have to reduce the fraction. So you have x plus, well, what is 10 force reduced to? 5/2. And then you have x minus 1/2, right? And then you do bottoms up. Bottoms up, bottoms up. So you end up with negative still on the outside. And you have 2x plus 5 and 2x minus 1. Does that make sense? It's just a matter of reducing your fractions. If you reduce your fraction and you still get a fraction, then just do bottoms up. Okay, that's it. Here's your table of contents if you're watching the video.